Well, thanks for allowing me to talk about this. There's a lot of similarities and a few differences with autotoxicity and herbicide carryover, but let's just jump right into this. As many of you know, successful alfalfa establishment is critical to meet all the things that we want from an alfalfa field, from environmental benefits to yield and economic benefits and everything else. But there's risks and challenges to this alfalfa establishment. And what I'm going to talk to you today about is not necessarily a new risk, but a risk we haven't thought about for a while. And that's herbicide carryover, which has been implemented as a large reason for some of these recent stand failures over the last 4 to 5 years, particularly in the Midwestern United States. So in order to kind of go through this process of what herbicide carryover is, we have to think about these herbicides. And we have to realize that these herbicides and a component, some of these herbicides have active ingredients that persist in the soil after we apply them. And that's often why we apply them too, right? As you can see in this picture that I have over here, where we have different plots that have different levels of weed control, where we're preventing those weeds from ever emerging. That's why we're often using these herbicides in the first place, either applying them before we plant the crop or the crop emerges, or even as a post-emergence treatment to get those late emerging weeds. And so that's the benefit of these herbicides. However, that herbicide that's in the soil needs to degrade to a certain amount. So when we come back to plant our crop, that crop doesn't get injured by that herbicide. And the challenge is the degradation of these active ingredients in these herbicides is very, very unique to the active ingredients themselves and other factors. And so it's complicated as to how long it takes these herbicides to degrade. So often when I get questions, I give a range of days to weeks, weeks to months, months to years, because of these factors. Again, the factors can be what active ingredients were sprayed, what rate that they were applied at. There's environmental factors that can influence how long they persist. And there's physical factors like soil-related factors. I'm going to focus on these environmental factors for today's talk. For example, soil moisture can have a large influence on the ability for these pesticides to break down. This is an example in a lab of pendimethalin or prowl, where we have half-life on the y-axis and percent of field capacity. So a sign of moisture, where a really wet field is going to be near field capacity and a dry field is not. And as you can see, is no surprise, as that field dries out, we get that herbicide persisting for longer periods of time. I want to also show you a graph with pendimethalin as related to soil temperature. So also soil temperature can influence breakdown. When the soil is warm, those microbes in the soil that are breaking down that herbicide are much more active, and breakdown occurs much, much quicker, as you can see here. But as the soil temperature gets a lot less, that time frame, how long that herbicide persists, is much, much longer. And I just want for later on, want you to look at soil temperatures of 50 degrees and see that takes 4 times as long for pendimethalin to break down under 50 degrees versus 80 degrees soil temperature. And we'll get back to that later on. Again, I want to emphasize breakdown is very specific to the active ingredients applied, but often soil moisture and temperature are big components. Soil type and organic matter can also matter, but we're really not going to focus on it for this talk. So what happened in 2023? Scott did a great job of showing you those results. Here's just some other graphs from 2 areas in Wisconsin. Here's Madison, Wisconsin on the left, and Darlington, Wisconsin on the right. The red line is our normal, typical rainfall patterns from May till middle of November. And as you can see in Madison, throughout the whole year, we had less rainfall significantly. As we moved farther to the southwest, we had a similar pattern, but we did get a few large rainfall events, which helped us out. So a little bit different between these 2 areas. But again, less rainfall than we typically would see. So we're concerned about herbicide carryover. because of this observation. You know, and it's really a challenge to deal with this herbicide carryover. And so labels try to account for this. They have tables like you see here, which give for certain crops, they give you a time frame of when you can't rotate back to that crop. And as we can see here with this one herbicide, 17 months is what's required. Some of them are now including some information on how much rainfall is needed, because we clearly recognize in dry years we can have carryover that occurs much more frequently. But a lot of other labels, like our atrazine labels, have taken a little bit of a different tact. They'll basically put some comments in saying, don't plant small seeded legumes like alfalfa the year following application, or injury may occur. So they allow you to plant it, but they give a kind of a warning saying it may be injured as a result of this. So just be aware, you can do it, but it's not our fault that it's injured because we warned you. And then we have others that will give a more standard table, such as you see here for alfalfa, and they give a 10.5 month restriction. This is for Resicor, but then there's footnotes, and always read the footnotes. In this one, I want to pay particular attention to footnote 7. And then what it says here is that Resicor is applied after June 1st, rotating to crops other than corn or grain sorghum the next spring may result in crop injury. And this is often what we're seeing, I think, with some of these carryover issues with Resicor. And they say you may get injury, so be on the lookout for it. So before we get into some examples of what these injuries look like and some other issues, why are we seeing increases over the last 3 to 4 years? I strongly believe it's due to the managing resistant weeds that are resistant to these herbicides, particularly water hemp. We're using a lot more products that have longer residual half-lives to control water hemp in corn and soybeans, because particularly it emerges later in the season. And we're applying them mixed in with our other post-emergent applications to get those later emerging water hemps, which means that they're present longer in the season as well. A quick survey of some of our common corn herbicides shows that over half of them have a 10-month or greater plant back restriction. If we're applying those in middle to late June and want to plant alfalfa the next spring, there's a good chance that we could be in that restriction time frame. So what are the symptoms of herbicide carryover? In some cases, they're fairly obvious symptoms. Like you can see in this picture, we have yellowing of leaves, even bleaching of leaves. The leaves are malformed, they're not growing as tall, and they just look bad. This is less likely than what we've seen in a lot of our studies, but this does occur, and I think this is what we expect. Unfortunately, what we're seeing, very similar to Kim's picture, there's much more subtle symptoms that we see, where we see some minor yellowing. There may be some reduced shoot growth, and we're seeing some below ground issues, but you can't see these issues. And so if you don't have something to compare it to, much like Kim said, you may miss some of these symptoms. As you can see here, this is a plot that was sprayed with a pre-emergent herbicide, and you can see a much thinner alfalfa stand versus this area on the left. But if you didn't have that for comparison, you may not think that is injured. Here's another example. This is of some interseeded research, but you can see in the foreground here, alfalfa looks really healthy. That second area, it's much less healthy, and you can again see that pattern continuing. So again, the key point is often it's difficult to see that injury if you don't have a not treated area. So this may be something you may want to think about if you're using these residual products, is having an area you can compare it to. Well, what active ingredients have a high risk? I used to say everything with 10-month or more residual. I think I'm pushing it back down to an 8-month plant back time frame. The ones that we're really concerned about are clopyralid and atrazine, and those are the ones that we're looking at with a lot of our research. But there's a whole bunch of different herbicides. If you're not sure what your plant back restriction is, be on the lookout in our Pest Management Wisconsin field crops. We have an appendix that lists what those plant back restrictions are. And we're hopeful to come out with a 1-pager or a 2-pager that summarize that for alfalfa. So be on the lookout for that this spring. You can download this guide for free at our pesticide PAT store, which I've listed there. So how do we research this concept? Well, right now what we're doing is we're doing bioassays in the greenhouse. And I'm just going to walk you through how we do this process. Basically, it's 3 steps. We collect field from the soil. We go out there and we collect it from areas that are treated and not treated so we can compare those results. We freeze those soils, and then when we're ready, we unfreeze them and put those in pots in a greenhouse. Like you see here, we put in sensitive species that we know are sensitive to that, what we're looked at. So in this case, we're concerned about alfalfa. So we'll plant alfalfa seeds into these pots, and we'll grow them in a greenhouse for weeks, usually 21 to 28 days. Now we're doing it up to 50 days, and we just simply compare what the growth looks like. In some cases, this is an example of an experiment. We see injury very quickly after 30 days with many of our treatments, with the control being to your far right. But what we've noticed is after 50 days, often in many of those cases, this is the same plants, they outgrow those initial injuries and look healthy, as we see with this treatment over here with Dual and some of ours with FlexStar, while some of them remain injured. We can look at the above ground biomass at 50 days. And what we see, that one that was really injured, Pursuit, at the long half-life rate, had about half the above ground biomass. Clearly, that's a problem. But all the others had similar biomass to our non-treated control. And what's really concerning is we're now seeing a lot of the impacts below ground are much worse than above ground, as we can see here, up to a 75% reduction in below ground biomass from that Pursuit treatment. And some of those recovered above ground still showed some of those below ground impacts. And there's just a picture to show you how wimpy some of those roots do look. So I want to just finish talking about a comparison of 2 bioassays from Wisconsin fields to kind of show you what we're looking at and some of the issues. One, we applied Resicor and atrazine at higher rates as a pre-emergent application in the middle of May. And another site, which is about 50 miles away, we applied Resicor and atrazine at half rates approximately of this other one as a post application. Without going into details, these soils were treated the same way. And what I'm going to do is show you the results of the undiluted 100% treated soil. And I'm going to compare it, since we didn't have non-treated soil, we diluted it 50% with a nearby soil that we knew was free from that herbicide, so we could look at those results. So first, looking at that atrazine and Resicor applied pre-emergence, what we saw is just very minor above ground injury, but about 30% less biomass in that 100% treated versus the 50% diluted soil, resulting in a little bit less than 50% less biomass. But in that post-treatment, which was again at half the rates, we saw much more above ground injury, the same amount of below ground injury, 30% reduction, resulting in around 40% less biomass. So why did we see more injury in this post-treatment site versus the pre? It doesn't make sense. Here's kind of the numbers of what the injuries were. Well, we did apply that post-treatment later, so that might have something to do with it. The post-treatment was applied 2 weeks later, but we applied it at twice the rates. Doesn't make sense. That post site actually even got less rainfall than the pre-site. So we would have expected a different response. In talking to the grower, a little bit more information that we found that pre-site was chisel plowed in the fall, a month prior to taking that sample. And so that's likely the reason why we saw much less injury in this scenario. Okay, so that's just some of the work we're doing. We're doing a lot more work right now looking at these and some other interactions. So stay tuned for some of that information as it becomes available. But how can you minimize that impact? Number one, follow those label restrictions, apply the label rate, follow those plant back restrictions, and read those footnotes carefully. Try rotating active ingredients in your cropping systems because you can get buildup in the soil if possible, and you're concerned about that. As Kim said, doing some type of tillage is probably the best thing that you can do to dilute that herbicide and increase the degradation of it. And potentially, if you think you're really close, waiting till later in spring when that soil warms up and you can get more breakdown can be another asset as well. Okay, I went through that fast, so let me just hit on some of the key points. We're seeing increased herbicide carryover in alfalfa. We think it's closely linked to resistant weed management. We need to be careful and follow those plant back restrictions carefully and be informed about what herbicides you're applying the previous year, when you applied it, how much, and follow those restrictions carefully. Unfortunately, the injury may be very difficult for you to view, and that's a concern. Below ground injury could be worse than the above. If you're concerned about that, we recommend planting a tolerant crop and work that soil to increase that breakdown. And with that, I'm probably right at my limit, if not over. I can check the chat box and I will stick around for questions afterwards.